Hey folks, welcome to my channel Number Pen. So today we have another interesting problem under the applications of differential calculus. You have the problem statement on screen. Few s- uh, let's take few seconds to read through the problem quickly. A particle moves along a line according to the law S of t equal to 2t cubed minus 9t square plus 12t minus 4, where t is greater than or equal to 0. So S here denotes the distance and t denotes the time. So at what times the particle changes direction? Find the total distance traveled by the particle in the first 4 seconds. Find the particle's acceleration each time the velocity is 0. So let's diagrammatically represent. I think that will help us understand the problem better. So let me draw and hope I get better at this as we move forward. So let's assume that we are here, right? Now, this is the origin. This is at 0. And so let's define key points, right? Let's define point A and point B here. And I'll probably come back to the diagram a little later. So let's write the equation first, whatever we have. So we have an equation here, and we know that rate of change of distance with respect to time is your velocity, right? So ds by dt is your velocity, and ds by dt is nothing but write the differential of this equation. 6t square minus 18t plus 12, right? So this is the velocity of the moving particle at any instant, which is denoted by t always greater than or equal to 0, right? So we've been asked to find at what time the particle changes direction. So the way we understand this is you have a particle, the particle moves from, say, a particular point, right? Now we need to find out at what point the particle is located. So let's, at t equals 0, we have s of 0 equals 4. So which means that, I'm sorry, minus 4. So we have the particle located here. Let me go back to the pen and pull this out. Let's let me let me denote this point as C, right? And let's denote this point as minus 4 and 0 being the origin, right? So O being the origin here. So this is the origin. Let me just highlight this origin, right? So we go back to the equation. So the particle at time 0 is at C, which is minus 4 from the origin, right? So so when does a particle change direction, right? So let's rewrite the velocity equation. I'm going to copy this in the interest of time. And let's watch this very closely. You see that this is nothing but 60 square. I rewrite this minus minus 12. I'm sorry, guys, about this. Rewrite this in the next line. So there's nothing but 60 square minus. Let me try factorizing this, right? I can represent 18t as minus 12t minus 6t, which is nothing but your 18t again. And let me factor this to figure out. I pull out 6. So what do? I combine these two equations. Let me probably highlight this. I combine these two, and then I combine these two as well, right? And I factor. So I pull out 6 again, and I have t minus 2, right? 60. So I can rewrite this equation as 6t minus 6, sorry, 6t minus 6, t minus 2, right? So my velocity is basically represented by 6t minus 6 into t minus 2. I can still further factor it by pulling out t minus, pulling out 6. 6 is a common factor. It's t minus 2, right? Now you watch this very closely, right? What do you mean by when the particle changes direction? So when the velocity is going to move from positive to negative or negative to positive, you have uh, the particle changing direction. So we have three combinations here. So the velocity becomes equal 0 whenever t equals 1 or t equals 2. And when we have t less than 1, we have velocity positive, right? And then we have t equals t greater than 2, we have velocity positive, right? So I hope you're with me. So when velocity is lesser than 1, you have t minus 1 and t minus 2, both are negative. So negative into negative is positive. So you have the velocity is positive. And when we are between 1 and 2, which is the next condition, right? 1 less than t less than 2, we have the velocity negative. And t is always greater than 0. So let's rewrite this first equation out here. 0 less than or equal to t less than 1, right? And t equals 1, the velocity is 0. And t equals 1, 2, or 2, right? The velocity is 0. So we have 3 points. We have 2 points when the velocity changes direction, right? So at t equals 2, we have velocity moving from negative to positive. Okay, and then at t equals 1, we have the velocity moving from positive to negative, right? So between 1 and 2, we have the velocity is always negative, right? So let me repeat this. So the velocity becomes equal to 0 whenever t is equal to 1 or t is equal to 2, right? So when t is equal to 1 or 2, the velocity is 0. And when t less than 1, you see that t minus 1 into t minus 2, which is nothing but a representative of the velocity, is always, and it's a negative into negative, which is positive. So v is always positive. And in between 1 and 2, you've got one positive uh, t minus 1 and uh, one positive t minus 1 and t minus 2 is negative. So you have the velocity is negative, right? And whenever t is greater than 2, you've got both the factors t minus 1 and t minus 2 positive, and therefore the velocity is positive, right? So the answer to the first question, right, at what times the particle changes direction, is This is where the particle changes direction, right? Now let's come to the second question, and I would like to probably take this up after we answer the third question because the second question needs a bit of additional thinking that we need to do or additional discussion that we need to do as we go through this problem. Find the particle's acceleration each time the velocity is zero, right? Now we see that the velocity is still dependent on time, right? Which means what is acceleration? Acceleration is nothing but the change of velocity with respect to time, right? So we again pull this up. Let me rewrite this expression here. D by dt of your velocity expression, which is nothing but 12t minus 18, right? So what I've been asked, find the particle's acceleration each time the velocity is zero. So when does the velocity become zero? The velocity is zero at 2 points, right? 2 points, which we discussed earlier. This is where, let me highlight this again, right? And dv by dt is the acceleration at t equals 1 is nothing but a simple substitution of this particular expression 12t minus 18, which is 12 minus 18, which is minus 6. And then at t equals 2, we have 24 minus 18, which is 6, right? So is 6. So acceleration is represented as meters per second square, right? Second square. Let me copy this. Yeah, so we have the answer for part 3 as well. So let me highlight this as well. And let's move on to the second part of the question, right? Now, let me go to the drawing board again to help us understand this better. So I've got 2 points here, which I marked earlier as a equal to 1 and a and b, right? So let's call this the point when t equals, sorry, t equals 1. And let me call point b as the point when t equals 2, right? So we've been asked to find the total distance traveled by the particle in the first 4 seconds. Now this is where many of us can go wrong, right? So we know that the particle is at location C minus 4 at time t equals 0. So the way we do this is the particle changes direction, right? Twice at t equal to 1 and t equal to 2. So the particle is located at point C at the time t equal to 0. And let's see where the particle is at the point t equals 1, right? So let me substitute t equals 1 into this equation, which is my distance equation, right? So 1 becomes equals to 2 minus 9, which is minus 7, plus 5 minus 4, which is 1, right? So you can see that at the time t equals 1, the particle has moved here, right? So the particle started from the point C, it moved to the point A, right? So let me draw this so that it becomes easier. We move this way, right? And let's call this step 1, right? And we know that at point A, we change the direction, right? So where are we at t equals 2, right? So let us again do the substitution as s of 2 equals 2 into 2 cube, which is 16, minus 9 into 2 square, which is 36, plus 12 into 2, which is 24, minus 4. So where are we? We are at 0. So what did we do? At the end of t equals 1, we reached point A from point C, And let me take my pen once again and explain this to you. And right, and then we moved back. Sorry about this. We moved back from point A to the point zero here to the point zero, right? At t equals 2. At t equals 1, we are at here, and at t equals 2, we are here, right? Right? And then again we change direction, right? We've been asked to find where are we for the first 4 seconds, right? At the end of first 4 seconds. So at t equals 4, what is the distance we have traveled? S of 4 equals, again I substitute 4 into this equation, which is 128, 2 into 4 cube, which is nothing but 2 into 64 minus 9 into 4 square, which is 16, which is 144 plus 48 minus 4, which is minus 16 plus 32, which is 28, right? So at t equals 4, what do I do? Well, let me go back, use the pen again, because this makes it a lot easier. I move back to a point, say B, right? Which is my final point at t equals 4. Let me just expand this and let me call this point as D, right? So we are at point D when t equals 4. And let me erase this to avoid unnecessary confusion, right? This is no longer required, right? And this is where we are when t equals 4. And this is t equals 2. And this is t equals 1, right? So let me repeat this. At point A, we are at when t is equal to 1, and when t is equal to 2, we are at point 0, and when t is equal to 4, we are at point D, which is we have traversed a distance of 28, whatever it could be, 28 miles, meters, whatever it can be, right? And at t is equal to 1, where are we? Let's go back to this sum, right? 1. So 1, right? And then so this is also 1 because we have come back to 0 at the end of t equal to 2. So we've been asked to calculate the total distance. So when t is equal to 0, we were at minus 4. So we traversed this distance of 4, and then we traversed this distance of 4 plus 1 to reach the point A, which is at the end of one. Let's take the end of one time unit, right? So we traversed 5. So let me go back now. So from 0 to 1 time units, we traveled, start from the point minus 4, we reached the point 1, so we traveled 5 units, right? From 1 to 2, we were at point 1 and we came back to point 0, so we traveled 1 unit, right? And from 2 to 4, we traveled 28 time units, right? At 4, we are at point 28. The reason I want you to pay close attention to this problem is because of the change of direction, right? So at times you can go wrong. A lot of us can go wrong by just substituting t equals 4 and arriving at the number that, the total distance traveled is 28. Now that's the right answer if you're always moving in the right direction, right? Let's assume for a minute there was no negative uh, in this expression, right? Let's assume it was 2t cube plus 9t square plus 12t plus 4 instead of minus 9t square and minus 4. Then at all points as t increases, s of t increases, right? So as time moves on, the distance you have traveled from the origin goes on increasing, right? So that's a different scenario altogether. Now this is a slightly tricky scenario that expects you to watch close attention to the points t equals 1 and t equals 2 where we change direction, right? So what's the total distance traveled here, right? So, because after 2, we don't change direction. So, from 0, we have traveled 28. I'm sorry, this is not time units, this is units, right? So, total distance traveled is 5 in one direction. Then we change the direction and then travel back 1 unit. And then again, we change the direction at t equals 2. We travel 28 time units until we reach the point at t equals 4 time units, which is 34, right? So we traveled 34 units is the total distance. So this is the answer for the question 2 of this section. So I hope you had a good understanding of this problem and the application of differential calculus. Thank you, folks. Stay tuned to my channel. Have a good day and subscribe to my channel if you like the problems and the concepts discussed in this channel around mathematics. Thank you.